Today we're going to continue our talk about constant rates of change and proportionality and ratios and equivalent rates with the conversation of slope. So we are going to learn about what slope is today, and we are going to specifically focus on how to find the slope of a line that is already drawn for you on a coordinate grid. We're going to split the lesson on slope into 2 days. So today we're basically going to be focusing on finding slope from a line that is already graphed for you. So we begin with our key concept, which is slope. Slope, as defined, is the rate of change between any 2 points on a line. So slope is calculated by calculating the change in y, which is the vertical change from one point to the next, over the change in x. So it's a ratio. It's a ratio of vertical change to horizontal change. In this particular line here that is graphed, if I pick any 2 points on the line, so for example, let's pick this point right here and this point right here, to get from this first point down here to this point up here, my vertical change is a movement of 2 boxes, and my horizontal change is a movement of 1 box. So the slope of this line is 2 over 1, or 2. In a linear relationship, the vertical change, which is the change in the y value, per unit of horizontal change, which is the change in the x value, is always the same. This ratio is called the slope of the function. The constant rate of change, or unit rate, is the same as the slope of the linear relationship. So, another way of looking at slope, again, since slope of a line is the measure of how steep it is or how slanted it is, again, we can look at it as the ratio of rise to run. So given any 2 points on a line, it is a calculation of the rise over the run. So in this particular line, the rise would be 3 boxes, the run would be 2 boxes, so the slope would equal 3 over 2 for this line. So we have positive, we have negative slopes, we have zero slopes, and we have undefined slopes. But if we focus on positive and negatives for the first few examples, if a line points downward as x gets larger or increases, its slope is negative, and if the line points upwards as x increases, its slope is positive. So in this line, since I'm going upwards, okay, as x increases, so I'm going up and to the right, this line has a positive slope. Now if my line was going downwards in this direction, this line would have a negative slope. So let's get calculating. Tell whether the slope is positive, negative, or negative, and then find the slope. So I look at this line and I know it is going down and to the right, so I know that the slope is negative, not positive. And they've chosen 2 points on the line for me. Now, typically, whenever we get to the point where we're choosing our own points, you're going to want to choose points that fall at exact coordinates. So I wouldn't want to pick like this point right here, because that point right there, it has uneven coordinates. So it's going to be something like 1.2 across and then 1.2-ish up, which we're not exactly sure if that's the exact coordinate. So we wouldn't want to choose a point that falls at uneven decimal coordinate points. So we would want to pick exact points because that'll cause our calculations or our counting pretty much to be easier. So whenever I calculate the slope, again, it is a ratio of the line's rise to run. I know that this is going to be a negatively sloped line. In this particular case, my rise is going to be 2. I go up 2 before I go back 3. Now, since that movement back is actually negative, that is going to explain to you why your slope is negative. So my final answer is going to be that my slope is negative 2/3. Another way of looking at this, and I'll put that in blue, is that to get from this point to this point, I actually go down 2 and then over positive 3. Because remember, a movement down is negative, a movement to the left is also negative, but a movement to the right is positive, and a movement up is also positive. Let's try another example. Oop, I went back. All right, tell whether the slope is positive or negative and then find the slope. In this particular case, I know that since this line is pointing up and to the right, the slope is positive. In this case, they have not chosen our points for us. So following what I said in the last slide, I'm going to pick 2 points whose coordinates are nice and whole numbers. So I know that this point right here on the line falls at 2 across -2. So I know this is the point 2, -2. And I know that this point right here is the point 0, -4. Now you might have looked at this and said, wait, what about this point, which is 4, 0? Okay, or even this point right there. So you could have picked any of these points. So I'm actually going to start with the 2 that I had mentioned, but then we're going to look at what happens if we all pick different points, because we could all possibly pick different points, but then we'll all get the same answer. So I'm going to highlight in red the original 2 points that I picked. I know to go from this point to this point, I'm going to rise 2 and run 2 boxes. So that means my slope is rise over run, which is 2 over 2 in this case, which reduces to a slope of 1. You could say it's either 1 over 1, which equals 1. Okay? In that case, my slope means that I go up 1 for every box that I run 1 in order to get from one point to the next. So let's say we had chosen, and I'm going to put this one in green now, let's say I had chosen this point and this point, I would have risen 4 and ran 4, and we know that 4 over 4 is also 1. So our slopes are still the same. So what slope is, it is a ratio that tells me how many boxes I need to rise, or what fraction of a box I need to rise before I can run to the next box. Now this here is a special type of slope. Okay, I have a horizontal line. If I pick 2 points on the line, any 2 points, okay, and I try to calculate my rise over my run for my slope, I know that slope equals rise over run. I notice that my rise is 0. And in this particular case, with the 2 points that I chose, my run is 3. But anytime I divide 0 by something, I get 0. So any 2 points I choose, I am going to get 0. So whenever I see a horizontal line, I know that that's going to be a 0 slope, because there's absolutely no rise, but there's a whole lot of run. So horizontal lines run forever and ever, but they never rise. So I'll have to remember that. Okay, so a couple of things to remember so far in review is that we have positively sloped lines, we have negatively sloped lines, and we have 2 other types of lines that are special. We have zero slope lines and undefined slope lines. So we know that positively sloped lines go up and to the right. So I could have a whole bunch of positively sloped lines so long as they go up and to the right. Negatively sloped lines go down and to the right. I could draw a whole bunch of negatively sloped lines. All of these lines here are negatively sloped. Zero slope lines are like that last slide that we just went over. They are horizontal. They have no slant to them. They have a whole lot of run and no rise. A whole lot of run and no rise. Undefined sloped lines are special. They are also going to fall in that special place where they're vertical. Now the reason that these guys are undefined, so let me draw a few more undefined slope lines, is similar to the reason that we have zero slope lines. So I know that if I were to pick 2 points on one of these vertical lines, let's pick those for example, I know that slope equals a rise over a run. I know in this case, I've picked 2 points that are 1, 2, 3, 4 boxes apart, and I have 0 run. Whole bunch of rise, no run. But anything divided by 0 is undefined. So we say that vertical lines are undefined slopes. Okay? Moving on along. One last example, just to review. Tell whether the slope is positive or negative, then find the slope. We know since it goes from the top to the bottom, so it goes down and to the right, it's going to be a negative slope. And to calculate the slope, we could use the 2 points that they gave us. We know that the rise here is going to be, I forgot to mention, it's a negative slope. The rise here is going to be 8 boxes, and the run here is going to be 2 boxes. Since it's a negative slope, I'm going to put in that negative. Negative 8 over 2 equals 4, which means that if I were to use different points, or if I were to start at this point, I could rise 4, run 1. Since my slope is technically 4 over 1. It is 8 over 2, but 8 over 2 equals to 4 over 1. So rise 4, run 1 should also work. Alright, now let's get into our problem of the day. Tomorrow we will be practicing basic slope problems. So problems just like 1 and 2 here, where you will just need to use the graph and the line to calculate the slope, and that is all. Tomorrow you'll watch another video for homework, and that video will talk more about calculating slope from tables and such type things. Okay? So have a good night, and I'll see you tomorrow.